Okay guys, welcome to Unacademy. So this is India's largest learning platform. Let me introduce myself. Myself Sunil Manjani. I have 15 plus years of teaching experience. Myself, I am an M.Tech in electrical engineering from VNIT Nagpur. I have mentored thousands of students for GATE ESE semester exam, and I myself have cracked PSU exams like GATE, HL, MAR, Discom, and MAR Genco. Okay, so let us go to steps how to use an academy learning app. Go to Google Play Store or App Store. Okay, install the Unacademy learning app. Okay, after permission and registration, enter Unacademy learning app and click on to manage goals. Okay, click on to GATE and ESE. Click on to plus subscription after that. Okay, in GATE and ESE, and then get subscription button. Okay, so you will be prompted for plus an iconic course. You selected plus course, so if you say this 12-month package costs you around 27 to 25 for plus, and 24 months package costs you 39,600. Sorry. Okay. Iconic package costs you 12-month, cost is 45 to 25, and for 24 month subscription cost is 66,600. Okay, again use my code SSM 10 for the discount. Okay, now what is plus subscription? Plus subscription, India's best educator educates you, interactive live classes, structured courses in PDF, live tests and quizzes. Okay, you can select plus here. In iconic you get all the features of plus subscription. Additionally you get personal coach, personalized test analysis, study planner, preparatory study material, and so on. Okay, so let us move to our topic, MATLAB Fundamentals. Okay, in this topic what we are doing is we are actually learning state space solution. State space solution. Okay, in this one we are actually using learning here in this session various form of state space equation. Various form of state space equation. And how to solve the examples of state space equation. Okay, so this is one step we are learning. Okay, now we will see step response using state space approach. Space approach. Okay, so for this state space approach, okay, there are two syntax. Okay, so syntax one is step A comma B comma C comma D, where A B C D are the state matrices. State matrices. Okay, input and output matrices. Or you can say that step is equal to, or step A B C D time t, where time t is time vector and it is user defined. User defined. Okay, okay, for Memo system, what is the syntax? So syntax is step A step A comma B comma C D I U N T. Okay. So here we are using separate input output relation. Separate input output relation. Okay. IU gives you input for obtaining response. Okay. So we'll take one example. Okay. So example is GS is equal to 16 upon S square plus 2S plus 16. You have to find out transfer function to, sorry, you have to plot step response using transfer function. Oh, step response using state space approach. So how the program will look like? So clear all CLC. What is numerator polynomial? 16. You can see numerator polynomial is 16. Denominator polynomial d1 is equal to, you can see, coefficient of s square is 1, coefficient of s is 2, coefficient of constant term is 16. So I will get 1, s is 2, constant term is 16. Okay, then I will print the system transfer function. Print sys n1 comma d1. Okay, then I will find out ABCD parameters, ABCD matrices. This is transfer function to steady state in bracket n1 comma d1. Okay, then after finding out ABCD, you need to write down step A comma B comma C comma D. Step A comma D comma B comma. So in this way you can find out step response. You can find out step response. Let us do this hands on. मैसेज कर Okay, so let us get the MATLAB load. Okay, so step function, step responses. So this is how MATLAB is loaded. Okay, so let us see. We will write down hands-on example. Okay, okay. So what was N1? 16. Okay. What was D1? 1 space 2 space 16. Okay. Then I will say parenthesis N1 comma D1. One additional command I will write down. So this will give you transfer function. Okay. B C D is equal to transfer function. Sorry. Uh, transfer function to steady state in bracket N1 comma D1. Okay, so we got A B C D matrices. Okay, then step A comma B comma C comma D. So let us wait. So this is our step response. This is our step response. So characteristics, peak time, settling time, rise time, steady state. So this is rise time, peak time, settling time, steady state, like this. Okay, if you can click on this, rise time is 0.317. Put the cursor here. Peak amplitude is 1.44. Percentage overshoot is 44.3%. Peak time is 0.829. Okay, put here settling time is 3.53 second. Steady state system final value is 1. Okay, in this way you can find out the response of a system using state space approach. Using state space. Okay, so example 2. Okay, here written that obtain step response of the control system of the control system having more than one input. Okay, so it is given x1 dot x2 dot is equal to -2 -1 2 0 x1 x2 plus 1 1 2 1 u1 u2. Okay, output matrix is equal to 0 1 1 0 x1 x2. Okay, in this way you can find out, you can write down the answer. So there are two outputs, y1 y2. There are two inputs, u1 u2. So we have got four responses. Four response. How? Y1 because of u1, y1 because of u2, okay, y2 because of u1 and y2 because of u2. Four responses. Let us complete this hands on. Okay, see the matrix -2 -1 2 0, that is A matrix. A equal to -2 -1 semicolon 2 0. B equals to 1 space 1 semicolon 2 space 1. Okay. C equal to 1 0 1 space 0 semicolon 0 space 1. This is C. Rather, I will say C equal to, not like that, 0 space 1 semicolon 1 space 0 space 0. This is C matrix. Okay, B matrix is 0. B matrix is 0. Okay. Or you can also write down D equal to 0 0 semicolon 0 0. So this is D matrix. Write down step A, comma B, comma C, comma D. Enter. So you get four responses. From input 1, okay, to output 1. From input 1 to output 2. From input 2 to output 1. From input 2 to output 2. So four responses you will get. In this way you can solve for this state space equations. State space equations. Okay. Let us solve one more example. Obtain step response of control system given below. Given below. X is equal to, sorry, x dot is equal to 1 0 minus 1 2 4 0 minus 5 0 2. This is equal to x plus minus 1 to 1 1 0 1 u. Y is equal to 0 3 1 minus 1 1 minus x. Okay. So 3 states and 3, how many inputs? 3 inputs. So see here, y is matrix 0 3 1 minus 1 1 minus 1 into x. What is the size of this? 2 rows 3 columns. Okay, 2 rows 3 columns. State matrix is how many states are there? x1 x2 x3. So it is 3 by 1. So if you cancel these two, y matrix will be 2 by 1. That is 2 row 1 column. y1 y2. So how many outputs? 2 outputs. Okay. Now input. Input matrix is minus 1 2 0. Sorry, 1 2 1 1 0. Minus 1 2 0. So what is the size? B matrix 3 by 2. What is the size of x dot matrix? 3 by 1. So we need a 3 by 1 matrix. So this will be 2 by 1. These two will cancel out. So we'll get 3 by 1. So u1 u2 is a u matrix. So two inputs. So two inputs u1 u2, two outputs y1 and y2. u1 y1 combination, u1 y2, u2 y1, u2 y2. So four responses you get. You will get. Okay. A matrix here is equal to 1 2 minus 5 0 4 0 minus 1 0 2. B matrix you will get as minus 1 2 1 1 0 1. C matrix you will get 0 1 1 3 minus 1 minus 1. 3 minus 1 minus 1. What will be D matrix? Nothing. What will be the size of D matrix? Okay. D matrix should be equal to 2 by 1. Oh, sorry. D into U matrix should be 2 by 1. U is 2 by 1. So D matrix will be equal to 1 by, sorry, 2 by 2. U matrix is 2 by 1. So this remaining matrix will be 2 by 1. D matrix will be 2 by 2. 0 0 0. Okay, so we'll do it hands on. Okay. So A is equal to 1 0 minus 1 semicolon 2 4 0 semicolon minus 5 0. Okay. B matrix is equal to minus 1 space 1 2 space 0. Okay, 1 space 1. So B matrix. C matrix is equal to 0 space 1 space 1 semicolon. Okay, 3 space minus 1 space minus 1 enter. So this is C 0 3 1 minus 1 1 minus 1. So this is C space. Okay, 0 1 1 3 minus 1 minus 1. What about D matrix? 0 0 semicolon 0 0. D is equal to 0 0 0. Okay, then what will be the syntax? Syntax will be step A comma B comma C comma D. Okay, then you can write down this. These are the signals. These are the signals. Okay, this is the step. So in this way you can find out step response for state equation or state space equations. Example 4 will say, or 3 rather, for today. Let us say that we'll consider a RLC circuit. This is not AC, this is DC source V. This is R, L, C. This is I. Okay. So let this loop current be I1. This is I1. Let this loop current be I2. This current is I1 minus I2. Okay. So let us say the solution. We have to develop state space model. Develop state space model and find step response. Okay. So here voltage across capacitor is VC. Okay. So state variables are I1, I2, 3 state variable. So KVL, this is loop 1, this is loop 2. Okay. So KVL to loop 1, what it will give me? Okay. It will give me V minus I1 R minus L d dt of I1 minus I2. d dt of I1 minus I2. Okay. KVL to loop 2 will give me L d dt of I1 minus I2. Okay. I1 minus I2 plus or minus Vc is equal to 0. So this is equation 1, this is equation 2. So 1 implies V minus I1 into R minus L di1 by dt plus L di2 by dt. L di2 by dt will give me 0. Therefore I1 R minus L di by dt di1 by dt plus L di2 by dt is equal to 0. So this will be plus, this will be minus. Therefore di1 by dt minus di2 by dt sorry, this is minus plus plus will give you I1 R by N. I1 R by N. Okay. This is equation number 3. Okay. LdI1 by dt minus LdI2 by dt will give me Vc. Will give me Vc. So LdI1 by dt minus LdI2 by minus Vc is equal to 0. This is 4. I will write down equation 2 once 3 once again here. Okay. Minus LdI1 by dt. Okay. Plus LdI2 by dt is equal to R by L into I1. R by L into I1. Okay. So in state space form, I will write down this is equation 3. State space form di1 by dt, di2 by dt. Okay. So minus, sorry, this will be minus L. This is L. This is L. This is minus L. Okay. This is 0. Oh, sorry. R by L. This is 0. I1, I2. You can write down this form 2 by 1. This is 1 by 2. So this will be 2 by 2. This is 2 by 2. This is 2 by 1. So this is 2 by 1. So this is not equal, correct? Okay. Let us check the form. This will be equal to I1, I2. So 2 by 1. We need the 2 by 1 matrix. 2 by 1. So this should be 2 by 2. 2 by 2. Okay, so R by L, this is 0. Okay, this is 0, this is 0. We are not taking VC as a third state variable. Okay, now we will expand to this to third state variable VC. What is VC? 1 by C, or rather I will say what is I2. See the figure. I2 is nothing but voltage across capacitor or current through capacitor. Current through capacitor is C dVc by dt. So dVc by dt is equal to 1 by C into I2. Okay, so for your convenience I will write down all three equations here. L di1 by dt minus L di2 by dt is equal to R by L into I1. Okay, minus L di1 by dt plus L di2 by dt minus Vc is equal to 0. Is equal to 0. Okay, what are state variables? I1, I2, Vc. So state variable matrix will be like this. This matrix, these two equations, A, B, and the equation dVc by dt. Okay, what was equation? 1 by Ci2 is equal to 1 by Ci2. This is C. These three equations, how I can write down? di1 by dt, di2 by dt, dvc by dt. Okay, this is equal to state equation. I will write down state equations. Okay, this was equal to V. This is not 0, this is V. This is minus V. Okay. So minus V let us modify this all these equations. So for loop 1, this is the equation. This is the equation. So I will solve this. Okay. So I will say L di1 by dt plus, minus L di2 by dt. Okay, so see, di1 by dt minus L di2 by dt. Okay, equal to minus 1 by r into I1, 1 by r into I1 plus V. V is the input. V is the input. Okay. Next equation is L di1 by dt minus L di2 by dt. Okay. Minus Vc is equal to 0. Okay. What is third equation? dvc by dt is equal to 1 by c into I2. Okay. So now we'll make an entry. This is actually equation A, B and C. Let us say equation A. di1 term L, di2 term minus L, dvc term 0. Similarly, B equation di1 term L, di2 term minus L, vc term dvc term 0. Okay, dvc term is 0. Okay, next is third equation. There is no di1 term, no dv term. dvc term is how much? 1. Okay, so now what we'll do is we'll just make a modification. This equal to 0 will be not, now this will be equal to vc, equal to vc. Okay, what are the state variables? What are the state variables? See, what are the state variables? State variables are three state variables: I1, I2 and vc. Size of this is 3 by 1, 3 by 3. This is 3 by 1. So if I cancel this size, LHS size is 3 by 1. So I need 3 by 1 here size. So this is 3 by 1. So this must be equal to 3 by 3. This must be equal to 3 by 3. Okay. So let us say I1 term, equation A, right hand side, minus 1 by r. I2 term 0, BC term 0. Here 0, 0, VC term is 1. Okay. Here 0, 1 by C, again 0. Okay, so this is, now I want input term. Input term, how many inputs are there? Only for loop 1, V0, 0. Is it like this? V0, 0. We want 3 by 1, so this equation will be 3 by 3. What is V1, 0, 0. Second term, V term is not there. Third term, V term is also not there. So if you multiply, you will get V00 like this. V00 like this. Okay, so this is the answer for state equation. Let us say that, sorry, these are the equations. We need only derivative terms in left hand side. Okay, so how is this term? Let us say this is equation, sorry, E matrix. This is X dot matrix. This is suppose B dash matrix, X matrix plus, oh sorry, this is suppose A dash matrix, X matrix, B dash matrix, U matrix, input matrix. This is the form we have gotten. Therefore, what will be X dot is equal to E inverse A dash. A dash is not transpose. Okay. Into X plus E inverse B dash into U. Let us put the values. R equal to 2 ohms, L equal to 1 Henry, C equal to 1, or 10 millifarad. 10 millifarad, that is equal to 10 e raised to plus 0 t farad. Okay, so this is the values of the components. Okay, so I will write down, this will be equal to okay, I will write down, this is equal to di1 by dt, di2 by dt. This is Vc is equal to, let me check, L minus L0, L minus L0, 0, 0, 1. Okay, so this is L minus L0, L minus L0, 0, 0, 1. Then I will get, this is inverse. Okay, inverse. Then minus 1 by R 0, 0, 0, 0, 1, 0, 1 by C 0. So minus 1 by R 0, 0, 0, 0, 1, 0, 1 by C 0. This is A dash matrix, state matrix or state. Okay, plus LL0 minus L minus L0, 0, 0, 1, inverse. What I will get is, which matrix? 1, 0, 0, 0, 0, 0, 0, 0, 0. Okay, 1, 0, 0, 0, 0, 0, 0, 0, 0. Then I will get input matrix. Okay, next I have to find out this, and I have to find out this. Okay, I have to find out this, I have to find out this. So let us see how we can do it. After finding out state, we need output equation also. This is state equation. Output equation. What is output equation? Y is equal to I1, I2, VC. Okay, I1, I2, VC. This equation I want. How to calculate this equation? Okay, this is 3 by 1. There are 3 states. So I will say how many inputs? 1, 2, 3. So 3 outputs. 3 outputs I will require. Okay. So I1, I2, VC. Okay. So like this output equation. This is the output equation. Okay. Let us do hands on this. Let us open the M file. Clear all CLC. L equal to 1 Henry, R equal to 2 ohms, or not at 1H, R equal to 2, C equal to 10 e raised to plus 03. Okay, so now let us see what is A, what is E matrix. What is E matrix? First of all, we'll go to our PPT. This is which matrix? Instead of E, I will say F matrix. This is A dash matrix. I will write it down here. This is A dash matrix. Complete matrix is A matrix. Okay. This is E or F matrix. This is B dash matrix. Complete matrix is B matrix. This is C matrix plus I require D matrix. Number of inputs are 3. Okay. So I require 1, 2, 3, 4, 5. Okay, so 3. Okay, so let us see. This is which matrix? D matrix. D matrix. So let us see. I will say F matrix is equal to F is equal to what is F matrix? L minus L0, L minus L0, 0, 0, 1. L minus L not here, here, okay. L minus L 0 semicolon L minus L 0 semicolon 0, 0, 1. Okay, A dash is equal to what is A dash matrix? Minus 1 by R 0, 0, 0, 0, 1, 0, 1 by C 0. So this is minus 1 by R 0, 0, 0, 0, 1, 0, 0, 1, 0, 1 by C 0. This is A dash. Okay. A matrix is equal to inverse F star A dash. A dash. Okay, this is A matrix. Now we'll go to B dash matrix. B dash. B dash is equal to what is B dash matrix? 1 0 0 0 0 0 0 0 0 1 0 0 semicolon 0 0 0 semicolon 0 0 0. This so B matrix is equal to inverse F, okay, star B dash. Okay, then we get C matrix. C matrix is nothing but identity matrix. C is equal to 1 0 0 0 1 0 0 0 1. C matrix. Okay, so this is C matrix. After C matrix, what we'll get is D matrix. Okay, so D is equal to 0 0 0 semicolon 0 0 0 semicolon 0 0 0. A dash A B dash B. Okay, A B C D matrix we have got. Okay, so next is we want to find out step response. Step A comma B comma C comma D. Okay, so let us say how many inputs? 3. How many outputs? 3. Okay, so V00 y1 y2, oh sorry, y1 y2 y3. Here input 1 v 0 0. Let us see how many responses we will get. Okay, we'll save this. Step state space. Okay, we will enter this. So we are getting quite infinite values. Okay, because of this I think if I take c equal to 1, and difference here is only of values. Okay, so don't bother about this, only of values difference is there. Okay, so in this way you can calculate, even though it is not a number, infinite number we are getting. Okay, you can calculate the value here. So let us check whether we are getting a infinity somewhere. Let us see the determinant. Determinant was 1 minus 1 0, 1 minus 1 0, 0 0 1. Let us see this determinant. Okay, minus 1, minus or minus 1 is 1, this is 1 and 0. Okay, so this is 1 minus 1 0 we are getting. So this is determinant, we are getting 0, therefore there is no inverse find out. Okay, that is the reason we are getting infinity. That is the reason we are getting infinity. Let us say that this is 2n. This is 2n. Let us say that hypothetical. Okay, we will save this. So whatever value you know, this f is coming out to be, determinant f is 0, therefore matrix inverse does not exists. Okay, so let us see this. See another system. Okay, so this is as good as memo system. Okay, so let us see another topic. Okay, response of arbitrary input. Okay, so LSIM this u comma t. Okay, this is the syntax. LSIM numerator comma denominator comma input comma variable t. Okay, this is transfer function. N is numerator, D is denominator. Okay, U is arbitrary input. T is the time vector. T is the time vector. Okay, so what if we have got multiple LTI systems, linear time invariant models? In that case, command is LSIM sys1 comma sys2 dash 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 sysn comma u comma t. Okay, now if you want output response, not the graph, output response and time vector t, so you will get the syntax y comma t is equal to LSIM sys comma u comma t, sys comma u comma t. Okay, so in this way you can find out the response of arbitrary input. Okay, let us say LSIM for state space approach. State space approach. So syntax is, what is the syntax? LSIM is equal to a comma b comma c comma d comma u comma t. Y is equal to LSIM a comma b comma c comma d comma u comma t. This is equal to LSIM. Okay, in this way you can find out output response and the LSIM syntax. Okay, so now let us find out some example obtain control system response for an input ut equal to e raised to minus 0.5 t. Control system is Cs divided by Us is equal to S plus 4 divided by S cube plus 2S square plus 2S plus 4. This is the control system response of a control system response for a particular system. Control response. Okay. So what will be the program? How I will write down. N is equal to 1 space 4 okay. This is okay. So 1 space 4. Then I will write down denominator is equal to 1 space, I'm sorry, 1 space 2 space 2 space 4. There is some hanging system hanging because of internet issues, okay, network issues, so bear with it. Okay, system is equal to transfer function n comma d. Transfer function n comma d. Okay, next command is we will define the time signal, time equal to 0 colon 0.1 colon 10. colon 10. Then u is equal to input, that is input exp minus 0.5 star t. Okay, then I will say LSIM sys comma u sys comma u comma t grid on. Okay, in this way you can write down the program. Let us say we'll define hands-on. Okay, let us say, okay, so clear all CLC. What was numerator? 1 space 4. What was denominator? Denominator was 1 space 2 space 2 space 4. Okay, then system equal to transfer function n1 comma d1, sorry, n comma d, n comma d. Okay, n comma d will define time vector 0. Okay, interval of 0.1 and up to 10. This is time interval. Input was exponential minus 0.5 into t. Okay, LSIM is equal to sys comma u comma t. Okay, then grid on. Okay, we will save this. So this is LSIM steady state space. We will run this program. So you can see the function. You can see the system response, linear simulation results, linear simulation result. Okay, so this is one program we are running down. Let us see another example. Okay, system is same. Example is convert transfer function model for arbitrary for control system given two state space model and obtain response response for an input u equal to 1 plus t square. One plus t square. U equal to 1 plus t square. Okay. So let us write the program, solution or program. Okay. So n is equal to, what was the control system? Control system was s plus 4 upon, this is transfer function. Okay. S cube plus 2s square plus 2s plus 4. This was the control system. N is equal to 1 space 4. D space is equal to 1 space 2 space 2 space 4. Okay. Then A comma B comma C comma D is equal to transfer function to steady state n comma D. Okay. T is equal to 0, 0.5, 10. U is equal to 1 plus T cap 2. T is array, therefore dot cap 2. Okay. Command is LSIM A comma B comma C comma D comma U comma T. Okay. U comma T. Then I will say figure 2 y is equal to LSIM A comma B comma C comma D comma U comma T. Then say plot T comma U comma T comma Y, input and output. Okay. You can also plot the style. You can also plot the style. Okay. So this is the style, isn't it? Dashed O. So let us do it hands on. Okay. On same I will do. Okay. So I will say this is like this. Okay. A comma B comma C comma D is equal to transfer function to steady state n comma D. Then T equal to this 0.5, this is 10. Okay. U is equal to 1 plus T dot cap 2. Okay. LSIM is equal to A comma B comma C comma D comma U comma T. Okay. So this is plot. Okay. Then I will say figure 2 figure 2. Okay, y is equal to LCM. Okay, plot t comma u comma t comma y comma quote dash 0 quote close, like this. So I will save this one and I will run this. Okay, this is 1 plus. This is figure 2. Of course, you got figure 1 also. Figure 1 also. Figure 1 and figure 2. Okay. So in this way you can plot the figures. Plot the figure. Okay, we'll do some juggling, okay, over the program. Okay, let us suppose input is exp minus 3 star t. Okay, and t is nothing but in the range of 0.2. Okay, this is 6. Okay, save it. Same function, run this one. So you can see the plot. You can see the plot. Okay, so this is how you obtain plots, okay, using state space. Okay, so let us see one example. One function is given as gs is 4 upon s square plus 2s plus 2e. Okay, it is a unity feedback system. Unity feedback system. Okay, you have to convert the transfer function to state space form. Transfer function to state space form and find out the step response. Okay, so let us write down the program. let us write down the program. Okay, so this is the program. GS, first of all, formulation 4 upon s square plus 2s plus 2. Okay, HS is equal to 1. So I will write down that is equal to 1 by 1. N1 is equal to 4. D1 is equal to 1 to 2. I can also write down this N1 as 004. Okay, then I can write down N2 is equal to 1, D2 is equal to 1. Then I can write down N comma D is equal to feedback N1 comma D1, N2 comma D. This is feedback system. This is feedback system. This is the program. Okay, this is the feedback. Then I can write down print sys N comma D, then A comma B comma C comma D is equal to transfer function to steady state N comma D. Then step A comma B comma C comma D. In this way I can write down the program. Okay, I can write down the program. Fine. So let us do hands-on for this. Let us do hands-on. Okay. So clear all CLC. Okay. Clear all CLC. N1 is equal to 0, 0, 4. D1 is equal to 1. Sorry, it is s square plus 2s plus 3, not 2. Okay. Okay, we'll take 2 only. 1 space 2 space 2. This is D1. Okay. N2 is equal to 1. D2 is equal to 1. Okay. Okay. So this is like this. Then I will say N comma D is equal to feedback N1 comma D1 comma N2 comma D2. Okay. Then I will say print sys N comma D Okay, then I will say a comma b comma, sorry, a comma b comma c comma d is equal to print a comma d comma c comma d, sorry, a comma b comma c comma d is equal to transfer function to steady state n comma d. N comma d. Okay, then you can say step equal to a comma b comma c comma d. Step SSS step. Okay, so this is step response. Let us see what is the transfer function. 4 upon s square plus 2s plus 6. Okay, in this way you can find out the response. Let us solve last example for today. Okay, same thing you have to find out. System is different. So example, gs is equal to 6 upon s square plus 2s plus 3 s plus 2. Straight away go to our hands on. Same thing. This is, see here, this is s cube term will be there in denominator. S cube is 0, s square is 0, s is 0, constant is 6. This will be equal to convol, okay, 1, 2, 3, okay, 1, 2, 3 in bracket, comma, convol 1 and 2, like this. Shift. Fine. So this is okay. Rest all the things are same. Okay. You can find system characteristics, peak response. You can find settling time. You can find rise time. You can find steady state time. Okay. You can find step info A comma B comma C comma D. Save this, run this, you will get step information. Okay, this is using steady state. Okay, in this way you can find out steady state response. Okay. So n1 s cube s square s n6, this is n1. d1 is equal to convol s 1 2 3 comma 1 2 comma 1 2. Okay, so after that n2 is equal to 1, d2 is equal to 1, n comma d is equal to feedback n1 comma d1, n2 comma d2. Okay, this is feedback. What is the other step? Other step is a comma b comma c comma d is equal to transfer function to steady state n comma d. Then step a comma b comma c comma d. Then step info a comma b comma d comma c comma d. Okay, so pretty much clear. Okay, fine. Okay, thank you. So we'll close this session today. Thank you very much for your kind listening. Okay, so how to unlock now free plan on Unacademy? As is the usual ritual here, Unacademy learning app, go to that in Google Play Store, install that app. After permission and registration, go to daily interactive live classes, select the goal GATE and ESE, select the popular goal GATE and ESE, then GATE and ESE select plus subscription. Okay, in step 5 you will click on a particular course you want to watch it for free, so free course. Okay, so click on that, you will be asked to put an invite code. Okay, put the invite code there. What invite code you will put in? For my class you put in SSM10. For other class also you can put in SSM10. Code is not class specific. Okay, so press unlock and this will be unlocked for free. Okay, so like us, subscribe us, put a comment on our videos. Okay, use my code SSM10 for offers, discounts, registration and more stuff. Okay, hit the bell icon for notification. We got telegram group also, join that group for latest updates on upcoming